Hello everyone. Today we are going to have a small recap of BigTable sessions we had earlier, and later we're going to see how to connect Hbase shell to a cloud BigTable instance, and followed by some 3 sample questions related to BigTable. Well, earlier we have discussed that BigTable is a fully managed, scalable NoSQL database service for large analytical and operational workloads. It can handle terabytes and petabytes of data with very low latency, and the benefits are speed, maintenance, and scale. So, due to this, Google Maps, Google Search, YouTube, Gmail are using BigTable in their backend. Now, BigTable is compatible with Hbase, Hadoop, Google Query, BigQuery, and Google Cloud Dataflow. So now this is easy to put all the data to work for your app. Today we're going to see about Hbase. The recap about instance, cluster, node, table, and tablets. Now, Google BigTable allows you to replicate data in 4 different regions around the world. Yeah. Now, about instance, a cloud BigTable instance is a container for your data. So here, when I create a table, this table it belongs to an instance, and BigTable has a limit of 10,000 tables per instance. Now, instances have one or more clusters located in different zones, and it can have up to 4 clusters. Here you see this is an instance. You can have up to 4 clusters. I have showed 2 clusters here. So when your application sends requests to an instance, it goes here. Those requests are handled by one of the clusters in the instance. So it is a BigTable service in a specific location. Now, one instance can have 4 zones. When I say 4 zones, you can have 2 region, 2 zones each, or 4 region, 4 zones. Say I create an instance. So I create a cluster in, say, Las Vegas, another one in Finland, maybe other one in London, and other one in Delhi. So I can create in 4 different regions and 4 different zones. Or I can create 2 clusters here in Las Vegas and 2 clusters in Delhi. So when I create 2 clusters in Las Vegas, I create instances in different zones. Las Vegas can have different zones. So when I'm creating an instance, I'm having a cluster in 2 different zones in Las Vegas and 2 different zones in Delhi. So that's the maximum amount of clusters I am allowed to in using Google. Now, every cluster in your instance serves your table, which this table belongs to the instance. Now, talking about nodes, each cluster has at least one node, which are compute resources that BigTable uses to manage the data. So now when I'm adding nodes to a cluster, it means I'm increasing the number of simultaneous requests that the cluster can handle. So nodes are responsible for making sure that the data is there to be read quickly. So if I'm sending 2-3 requests to the table, so each request is handled by nodes here in the cluster. Okay, now moving on to tablet. Now behind the scene, Cloud BigTable splits all the data of a table into separate tablets. A tablet is associated with a single node. Okay, so this tablets, they help in balancing the workload of queries. So when this requirement is, when a request is sent to a node, these tablets, they balance the workload of queries there. Okay. So that's about instances and clusters and table and tablets. Now, talking about storage type, SSD is significantly faster and has more predictable performance than HDD. Now, HDD is data archival, where you write a very large amount of data, but you rarely read that data. Okay, now on the other hand, if you plan to use the data to display a real-time dashboard, then SSD is a better option. So that's about the storage. Schema, coming to schema, it is a blueprint or a model of a table. So schema is the structure of the database. It defines the objects in the database here. So now this is an example how a table looks like in a big table. So a table, it stores the data in massively big tables. Um it's composed of rows and columns. So big table stores data with similar schema in same table rather than in separate tables. See, now these two are column families. Okay, now all data within a column family is usually of the same type. And this is the row key. Now each table has only one index, the row key. Okay, now talking about cells, cell is the intersection of a row and a column. So see, this is the intersection. See, you have a row key and the intersection of both the column families. See, the data related to students is in one column family, and the data related to branch to which these students belong to, they are in one column family, and they are indexed. This is a row key. Okay, so that was the recap. Now talking about what is Hbase shell. Yes, Sana.
Yeah, so in the column families, are we deciding those column families or in the schema, or how do we decide the?
Yes, yes. We decide the column families. So when we are designing the schema, which later we'll talk about, um, we will group them together.
Hey, so I have one question here.
Uh-huh.
So here, like we are, it's like we with the row key we are joining two tables here, right? With row ID, student ID.
This whole thing is a table.
But the student table and the branch table are two different tables, right? I
They
mean
are
to say
two
two
different column
different,
families in the
yeah,
table.
column families. So what if like
Yes.
we have the third column family and
Mhm.
which is also part of this family, so it will get
Yeah.
added in it,
Yes.
or
Yes.
means it
Yeah.
it get
It gets.
handled along with this?
Yes, it can handle.
Okay. And up to like how many you said like 1,000 tables something can be added in one this thing, right?
Yeah. You can add up to 1,000 table per instance.
Per instance, yeah. Okay.
Yeah.
Okay. Yeah.
Yeah.
But this is one table, right? One table with
Yeah.
multiple
This is
columns,
just a sample table. It's not one table. It's just a sample table. The tables are really very huge.
and we can have as many column families in that.
Yes. Yes.
Okay.
Okay. Now, what is Hbase shell? Um, Hbase is a column-oriented, non-operational database management system that runs on top of Hadoop Distributed File System, HDFC. So where is it used? It is used when you need random real-time read and write access to your big data. This project's goal is to hosting of very large tables, like millions of rows and billions of columns. Pinterest, HubSpot, Tumblr, Hbase, Burada, Double Splash use Hbase. Now today we will connect Hbase shell to a cloud BigTable instance. So for that, we're going to create a cloud BigTable instance quickly and then connect BigTable instance with Hbase shell, read and write, and then later we'll delete the table. Moving on to Cloud Console. I've selected my project there. I go to BigTable, quickly create an instance. We have seen this earlier, how to create an instance. I just say okay. Maybe I'll just go with a better storage type, SSD. This is the cluster ID. I'm going to choose the region which is close to me, Virginia, and select the zone. See, now I can have 2 clusters in Virginia, but in a different zone. Okay, I can show you here. So this is the second cluster. I'll choose the same region, Virginia. See, this is grayed out. So I cannot have 2 clusters in the same zone. This is what I mean. You can have it in a different zone. I'll add it. Then I'm going to create the instance. Okay, that's created. Now I'm going to activate the Cloud Shell. Here I'm going to clone the GitHub repository that contains the Hbase shell, quick start setup scripts, and this is I have saved it here. I'll share these at the end. Yeah, actually I added it earlier, so I already have that created. So now I'm going to connect the BigTable with Hbase shell. So I'm going to go into the quick start directory. So okay. Now I have to reconfigure the version of Java. So this is the and I'm going to quick start. I authorize. It's just going to take some time. I get this error from the second time I have practiced this actually, but it works. Now once Hbase is connected, I'm going to create, now in this instance, I'm going to create a table I'm going to name the table as student, and with the column family, say information. Okay, so okay, there are no tables there. So this is the command. Here I'm creating the table called student, and the column family is information. Now, since that's done, I'll fill in some data, put some data in it. So I'm going to put in this table, student table, R1 uh, is the row key. I'll show you here. Yeah, it's the row key. Okay, and information is the column family, and this is the column name, and this is the value I'm going to put there. I'll put few more details in the same column family. I'll put few more details. So I'm putting the name. Earlier I put the ID, and then I put the name, Charlie, and his location now. Okay, now I can check that. See, the row key is same. I get all these values here. So I created the instance, created a table with column family, say information, and then I put in some details like his student ID, and his name and his location. Okay, so after this, I'm just trying to delete it. In a typical scenario, maybe in a live environment, you would not delete um, unless you don't want the data anymore. So that's done. So once that is done, I delete my instance as well.
So, Haripriya,
Yeah.
you kept the row key as one to associate as the column family. Is that why you kept it one? I think.
A row key is one. See, here I just created one row key. The row key is one here, and I created his name, and uh, his ID, and then his location.
Okay. Okay. So, and the
The
student
whole.
that you gave in between was the name of the table.
Correct. Yes.
Okay, and information was the column family.
Correct. You're right.
Okay. So there is no way where we can put the entire row in one command. Like you used three commands, right?
Yeah, I
To
use three commands.
can you
I'm not
that?
sure about that. Sana, maybe I can check on that and let you know.
Yeah, sure, no problem. Thank you.
Thanks. Um, well, moving on to few sample questions. I chose some simple questions today. They're simple ones. I'll read it out. What happens when a cloud BigTable node fails? All data will be lost. No data will be lost. The last transaction will be lost. and the last option is none. Here, the correct one will be no data will be lost, because we would have created clusters in different zones. So if one zone fails, there is data in the other zone. The next one is, you expect to store at least 10 terabytes and plan to use the data to display a real-time dashboard. When you create a cloud BigTable instance, which storage do you choose? SSD, HDD, switch to SSD from HDD, or any? Here the keyword is real-time dashboard, and it's at least 10 terabytes. Now, the right answer will be SSD, because I'm looking at real time. Okay, and the third option will not be right, because you, once the storage type is fixed, you cannot change that. The only way is you have to move the data and create a new instance all over again. So here the answer is SSD. The last question is, in BigTable, what is responsible for keeping track of specific tablets on disk and handling incoming reads and writes for its tablets? Nodes, Hbase, shell, table, project. Here the answer is nodes. The tablet is associated only with a node. Not these three options would be ruled out immediately.
Hey, Haripriya, a quick question. This is awesome. Where did you get these questions, or did you create it on your own?
Um, I think one or two questions I created, but otherwise, Tim, there are quite a few videos on YouTube. If you just search with keywords like BigTable, sample related questions,
Okay.
GCP, BigTable, or storage related questions, there are few questions
Okay.
on the
All right.
YouTube.
Cool.
And also few websites. I think in the questionnaire that I have sent you, I've sent you some 30 odd questions. I've also included the source from where I got those.
Got it. Okay. All right. Cool. Thanks.
Yeah,
Haripriya,
that's it.
I have a question.
Yes.
Can you show the slide of the first question?
Yeah, sure.
So, if one node fails, you were mentioning there will be another zone, right? But there are another nodes and other cluster in the same zone. They are functionable, right?
Yes, yes. Yeah.
Okay. Thank you.
Welcome. Yeah, that's it from my end, guys. Thank you.